Over a year ago, I started working on a project, and I wanted to integrate this infrared remote into it. And after 4, 5, 6 hours, I gave up. It was just supposed to be a rainy day project, and it started running over. So I finished up the other part of the project, and I left this sitting on my desk for over a year. Yesterday, I finally said, okay, this is do or die. I'm going to make this happen, or I'm going to throw it away. And yeah, there were a lot of problems. I couldn't find a good example under the IDE. The IDE has a lot of examples. The examples there were all version 2 of the old libraries, and I don't want to go backward and start reinstalling old libraries. That's a real mess. I want it to be current code. So yeah, and I couldn't find an example that worked. I mean, there was a lot of things that, I don't know, just didn't do anything at all. So I fought with it, and finally got it figured out, got it to work. Let's do a quick demo. This is the power button. Now, come up here. Now, this is the view today. Good news is you don't have to look at me. We've got this set up as an example. Clear the screen. When I push the power, it'll say on off. Here's the menu button. I push the menu button. Test button. This is channel up, channel down. This is the play button. This is the reverse play button, skip ahead button, and then of course the numbers 0, 2, 8, or 5, can't read, 8, 9, clear. Okay, when you get this error, it says, I didn't clearly see the message, I didn't clearly see the digital input, so that's the C, and this is usually ignored. Okay, so this is working exactly as it should. Finally. Okay, so we've seen the example. Let's go down here and take a quick look at the hardware. This is the easy part, and then we'll take a detailed look at the code and see what was so difficult about it. This is the Arduino Wemos D1 Mini, and I'm using the IR remote HW477, and you can see that here, and it's the same one that's here. This is the remote module right there. And of course, this is the Wemos. I've got a data shield underneath here that has a real-time clock and an SD card, but that's not necessary for today's project. You can see that there's only 3 wires. There's the signal wire, which goes to D2. There's VCC, which comes over here to 3.3. And then there's ground. And of course, for reference, that's the USB plug. So yeah, that's all there is to it. That's very simple. And again, this is why, with 3 wires and all, I thought this would be a slam dunk and I'd be done. Okay, so let's go look at the code in detail. To be a bit repetitive, this is code based on the Arduino Wemos D1R1 Mini. The hardware, the IR hardware, is the HW477. It's NEC protocol as close as I can tell. The VCC on the IR goes to the 3.3 on the Arduino. The negative on the IR goes to the ground on the Arduino, and the signal on the IR goes to the GPIO4 D2, or you can also use the D0. These both work. I've tested both of these, even though I have the shield on there with the SD card and the real-time clock. These are 2 available pins. Here is one of the gotchas. This is one of those things that was tripping me up. The IR remote.h version 3 routines, they return least significant byte codes. Now, why on earth they made the change from most significant byte to least significant byte, I do not know. But rather than write a routine to try to go through and flip those around, it's just faster for the machine not to have a routine, to have to go through it every time you push a button. I just forced it. I mean, brute forced it. I looked at every hex code that was coming out of the remote, and I took that hex code the way it was, and that's what's down here in this case statement. So yeah, this is not the best way to make portable code. It won't work with other stuff that has most significant byte, but as they say in business, SEP or NMP. Okay, onward. I'm done whinging on that for a while. We include the IR remote library, and then we define this constant byte. So this is the pin that we're going to use, and we've already gone over that several times. This is the very familiar setup routine, and I'm using 9600 on the serial, and that's for the COM3 over here. The IR receiver, this is one of the new commands, and it's very different than the old way of doing it. IR signal pin, so that's this from up here, and we're enabling the LED feedback. So we're just opening up the IR receiver serial communication. This is the void loop, and it's looking for information to decode if it's out there. This next line is what I was using to grab the hexadecimal codes, and it's just a debug thing. I'm not using it anymore. So I do switch on the decoded raw data. So this is what's coming back from the IR receiver. And this is the first one. This is the power button. When I push the power button, this is the code that the remote sends. And it's what the IR receiver receives. And it prints the on-off. Now normally you don't print on-off, right? You're going to grab this case and you're going to put your code in here and you're going to turn your device on and off. And that's true of all of these. I won't go over all of these in detail because, yeah, I think you probably know at this point you're going to replace this serial print line with whatever you need. This is the code for menu. This is the code for the test button, and so on and so on. We saw these in the example. And it goes down here. And then all it does is it does the IR receiver resume. So it resets the serial communication with the IR for the next round, and it just loops again waiting for your input. So yeah, once you see it and once you work through the headaches of this stuff back up here, it's not that bad. Well, that's it for today's Arduino effort. Hope you found this useful and interesting in your coding and electronics work.